Hey everyone, today I'll be solving the question increasing subsequences that came in educational Codeforces round 161 rated for Div 2. In this question, you'll be given only x that has a very large range that is up to 10 to the power 18, and you need to print a array, and that array must contain exactly x increasing subsequences. And you know that the subsequences by deleting some or none of the elements from the array, that will be a subsequence. And and if the subsequence is empty, that is also increasing. It means you have to have exactly x minus 1 increasing subsequences, that is non-empty increasing subsequences. So how can we have that? Let me explain it using the whiteboard. Let's say if you have only one element, let's say y, then how many sub sequences you can have? It's one. You can say 2 to the power of 0, it is. And you can print any element, so let's say it is 0. If I have only 0, it means it's a one subsequence I am having, one non-empty. Now if I have 1, 0 and 1, then how many subsequences that one can form? It can be like, if I have 0 over here only, that is only one subsequence. Now how many subsequences one can form? That is only one, or I can include 1 in front of 0, so it could be 0 1 also. So the number of subsequences one can form is 2 to the power of 1. Now, if I include 2 over here, the how many subsequences 2 can form? By including 2 in front of 0, or in front of the subsequences that 1 have formed, or in front of the subsequences that 0 have formed, and 2 alone. It means 0 2, 1 2, 0 1 2, and 2 alone. So how many it will be? It will be 2 to the power of 1 plus 2 to the power of 0 plus 1. That is 2 to the power of 2 basically. 3 plus 1, 4. That is 2. If I write 0 1 2, 0 2, and 1 2. 0 2, if I write it 1 2. That the subsequences that only 2 can form. These are the subsequences, and so on. If I include 3, then it will be 2 to the power 3 subsequences that 3 can form. Now, if I want, let's assume the value for x now is 30. Now, if I'm including 0, 1, 2, 3, then total number of subsequences that these are forming, which are non-empty, is 15. Like 2 to the power 3 plus 2 to the power 2 plus 2 to the power 1 plus 2 to the power 0. That is 15. Now, if I include 4, but that will be forming 2 to the power of 4 subsequences. That is 16. But I'm left with only 15 subsequences that I can form. So what I'll do is, I cannot put 4 over here, but can I put 3 again over here? Yes. But how many subsequences this will be forming? This will be forming same as this 3 has formed, because it can be in front of all the subsequences that 2 has formed, all the subsequences that 1 has formed, and all the subsequences that 0 has formed. It can be in front of all of them, but cannot in front of all the subsequences that 3 has formed. So it can create 2 to the power of 3 subsequences again. That is 8. Now how much I'm left with? I'm left with 7. Now can I put 2 to the power 2 again? Let's say I'm putting 2, then it will be forming same as 2 to the power 2 subsequences, because it can be in front of all the subsequences that 1 has formed and all the subsequences that 0 has formed, same as this 2. So it will be 2 to the power 2, that is 4. Now I'm left with three subsequences. Can I put one over here? Yes. It will be forming the same subsequences that one has formed 2 to the power 1. Now I'm left with one subsequence. So I can put 0 again. So this kind of thing I can put in my array. Yes, this kind of thing. But how can I assure that there could be exactly X subsequences? Because let's say X is anything, but after this, let me clear it. Up to this, the summation was 15 of 0, 1, 2, 3. Now, if after this the remaining X over here is anything lesser than 16, because I cannot put 4. If I am putting 4 over here, that will be 16 subsequences that 4 will be formed. So I cannot put 4 over here. It means that is something lesser than 2 to the power 4, the value of X. The value of X lesser than 2 to the power 4. Like 2 to the power 4 is 0, 1, 0, 1, 2. This is. So that is the value of X is something that can be created with the four on the 4-bit positions, and that thing I can create with 2 to the power of 0. That is from having a set bit over here, having a set bit over here. That is 2 to the power 2, 2 to the power 3. I can create, like I can have 2 to the power 3 again by putting 3. I can have 2 to the power 2 by putting 2. I can have 2 to the power 1 by putting 1. Yeah. Using those set bits, I can definitely create anything with this 4 bit position, because um, I can put any bit, any set bit over any position, because I have that 2 to the power 3, 2 to the power 2. I have set bits for this position also, for this position, and this position. So I can put at any position for sure. And that remaining X can be formed, which is lesser than 2 to the power 4. It means it is anything created with this 4-bit position, because it is lesser than 2 to the power 4. It means I cannot have a set bit over here. I'll be having 0 over here, and anything in this 4-bit position. And if don't want to put, let's say, remaining X is 110. 110 is anything, I don't know. That is 110. Now, can I put 1 over here? That is 0, 1, 2 to the power of 1. Yes, I can definitely put. If I put 1 over here, that will be forming 2 to the power of 1 subsequences. And can I have 2 to the power 2? Yes. If I put 2 over here, that will be forming 2 to the power 2 subsequences. It means I can have 3 subsequences, like 2 to the power 2 and 2 to the power of 1. That is 5 subsequences using those. So using 2 to the powers, I can create anything now. But how can I assure that it will not go beyond 200 element? Because let's say if I am having 100 characters, 100 elements in front, that is 2 to the power 100 plus 2 to the power of 2 to the power 99 plus 2 to the power 98 up to 2 to the power of 0. But I'm assuring that 2 to the power 99 is definitely greater than 10 to the power of 18. So we will definitely have lesser than 200 characters, because if I'm having 100 characters in front and 100 characters in the decreasing fashion, then it will be creating something greater than 2 to the power of 100. So that is greater than 10 to the power 18. So I'll definitely have lesser than 200 characters. It will be around 60. It can go around 60 to 70 at max. So this is the intuition. If I'll explain the code, it will be more clear. Let me explain it. I've taken X and reducing X by 1 because of non-empty subsequences. Be- now, why X is greater than equals to sum? Now my current element is 0. So the number of subsequences using that current element is 1, definitely, because 2 to the power of 0. No, I'm reducing that summation and sum into 2, because then if I want to include 1, that will be having 2 to the power of 1 subsequences. So if it is 1, then again 2, and I'm increasing my current, that is 1 I'm using, 1 that I'll be using next, and I'm just pushing into my answer. No, x become lesser. Now I want to insert some elements in the decreasing fashion. I reduced 2 to the power 1 plus 2 to the power of 2, that I have reduced from x. Now, as I have told before, in this case, like if I cannot put 2 to the power 4 over it, that is x becomes lesser than the summation, that is the total summation that I am having currently. If it is lesser, like summation is 2 to the power 4 now, and x is lesser now. So while x is not equals to 0, so I can put any bit position over here. So current is 4 now. I'm reducing current. Like which element I can put? If x is greater than 2 to the power of current, then I'll be pushing that to my answer, and I'll be reducing that from x, because that element has been used, and reducing the current again. As I've told, like in this question, I can put any set bit position. Like uh, in this case, if I'll be searching for, then if it is lesser than 2 to the power of 2, if 2 to the power 2 is lesser or equal, then I can use that 2 for sure. As in that case, if it is 5, 5 is greater than 2 to the power of 2, so I can use 2 over here, because that will be creating of number of subsequence, that is 2 to the power of 2, which means it's 4. So if it is, then I can use that current, and I'll be reducing that, because it will be creating 2 to the power of 2 subsequences that I'm reducing. If I'm using current, that will be forming 2 to the power of current subsequences that I'm reducing from the x, and I'm reducing current also, because as I have used that, I cannot use that again. Like I can use that again if I am having 2. If I'll be putting 2 again, then that will be again creating 2 to the power 2 subsequence. But as I know, I'll be in that case, as I need to form something with this 4 bit positions, 1 2 3 4, as it was lesser than 2 to the power 4, x is something lesser than 2 to the power 4, so I need to create something within using this 4 bit positions. So if I have put 1 over here, let's say something, let's say x is the largest one that I could have, that is 1 1 1 1. Now my current is standing over here. Now 2 to the power 4 currently is at 4, so 2 to the power 4 is definitely greater than x, so I cannot afford, so I'll be moving over here. So can I have 2 to the power 3? Yes. So I'll be cutting down, then again I'll be moving. I can reduce that, because I have reduced that 2 to the power 4, so I am reducing that current again. So that's why I'm reducing over here and pushing that to my answer, then printing the size, and then all the elements of the answer. Thank you for watching.